Standard large language models are powerful, but have a critical flaw. They become very slow and require huge amounts of memory when dealing with long pieces of text. This is because of their core component, softmax attention, which doesn't scale well. The paper we're discussing introduces a solution called Lizard. It's a framework designed to modify these existing powerful models to make them much more efficient without starting from scratch. Lizard's main objective is to allow models to handle text of virtually any length, overcoming the current limitations. Figure 1 illustrates Lizard's two-stage training approach. It's a process that avoids the massive cost of training a model from the ground up. In the first stage, new efficient attention modules are trained to mimic the original, powerful but inefficient softmax attention of a pre-existing model. The original attention acts as a guide. Once the new modules have learned their lesson, the old attention mechanism is swapped out. In the second stage, the newly modified model undergoes a final round of training to ensure all its parts work together effectively for language tasks. The key to Lizard's efficiency is its unique hybrid architecture. Instead of relying on one method, it combines two. First, gated linear attention acts like a compressor for the entire document, summarizing the global context. It has a smart gate that learns what information is important to keep from the distant past. Second, sliding window attention provides a sharp focus on the words immediately surrounding the current position, capturing local grammar and meaning. This dual approach allows the model to process incredibly long texts while using a fixed, predictable amount of memory. Figure 2 helps us see how Lizard's attention works. On the left, the gated linear attention shows a broad view of the past, with older information becoming less prominent. This is for understanding the overall topic. The middle panel shows the sliding window attention, which is intensely focused on just the last few words to get local details right. You can also see the special meta-memory tokens, which provide a global summary available to every word. The final panel on the right shows how Lizard combines these two views for a complete picture. The researchers tested Lizard thoroughly to validate their approach. On common language tests, Lizard performed almost as well as the original, less efficient models, which is a big win. In a needle-in-a-haystack test, where the model had to find a piece of information in a long document, Lizard excelled, proving its excellent memory. Efficiency tests showed that Lizard could handle very long texts without running out of memory, unlike the original models. Finally, they showed that every part of the Lizard design was necessary for its success. Table 1 provides a direct comparison of Lizard with its peers. The key finding is that Lizard models perform exceptionally well, nearly matching the original, computationally expensive models they are based on. When we look at the MMLU score, a difficult test of general knowledge, Lizard significantly outperforms other models designed for efficiency. It also proves superior to lolcats, another model conversion technique, especially because Lizard can handle texts of any length, not just the length it was trained on. This is a powerful visual test of long-term memory. The task is simple. Find a hidden phrase in a long document. The original Llama model does this perfectly, but can't handle very long documents. The lolcats model fails completely once the text gets longer than its training has prepared it for. But Lizard, on the right, is a sea of green. It successfully finds the phrase every time, even when the document is much longer than what it saw during training. This clearly shows Lizard's strength in long context recall. In conclusion, Lizard offers a practical and powerful method to adapt existing large language models for long context tasks. Its hybrid attention mechanism is the key, providing both a bird's-eye view of the entire text and a detailed focus on local information. This allows for constant memory generation, a huge leap in efficiency. Most importantly, it achieves this without significantly compromising the model's performance, making it a standout solution compared to previous approaches. Lizard effectively makes state-of-the-art models ready for real-world, long document applications.